Wakanda forever! Welcome, everyone. Welcome. Yes, you have a special guest teacher today. It's none other than Black Panther. Yep. We're going to get right to start. 9.58. What is the binomial theorem? All right, the binomial theorem. Let's see what kind of powers it has. Wakanda forever! All right, now, I'm going to show you guys two different patterns. First, this one. Do you notice a pattern here? And write down anything that you notice, okay? So stop the video and write down anything that you notice. So I'll show you first this pattern here. Stare at it. Stop the video for a little bit. Come back to it. Okay. Let's see what you wrote down, but not just quite yet. Also, okay. You know what? Let's actually discuss this really quick before I do the other show. Before I show you the other pattern. All right. What did you guys write down? Now, if you guys can give yourself some points, okay? If you got any of the ones that I mentioned, you give yourself a point, okay? All right, ready? Did you see that? I have a couple things for you. But did you see that in each expansion, this is called just this guy right here, and it's been expanded, right? You know that x plus y squared is x squared plus 2x plus y squared. It's been expanded. In each expansion, did you notice there are one more than n here? So n plus 1, n plus 1, n, 1, 2, 3, n plus 1. Do you guys get that? Give yourself 2 points for that. That's the hard one to notice, okay? Number 2, in each expansion, x and y have symmetrical roles. Symmetrical roles. You don't need to write all this down. Symmetrical roles, we'll discuss what that is later. The powers of x decrease by 1 in successive terms, whereas the powers of y increases by 1. What the factor is that saying? The powers of x decrease by 1. The powers of x 2. So this one's 1, nothing, 0, right? There's 1 here and then nothing here. That's why it's 0. Okay, powers of 1. Let's see. 2, 1, 0. 3, 2, 1, 0. Oh, okay. Okay, so we get that. And then powers of y increase by 1. And you can see that too. Because it was 0 here and it's 1 here, squared here, and 3 here. I'm just showing it with the higher degrees because it's easy to see the symmetrical role. And you see how it's balanced, right? 3, 1, 2, 2, right? They have symmetrical roles, okay? 3, the sum of powers for each term is n. Sum of the powers of each term is n. Let's see, okay? 3, 2, 2. 1 plus 1 is 2. 2 is 2. 4 and 1 is 5. 3 and 2 is 5. Did you guys put that? If you got that, give yourself 3 points for that. This one may be one roll. A 1, okay? Let's try this guy right here. Oh, this shows you here. Okay, you can see how the powers of each term adds to the n, which is the exponent, okay? Did you also get that coefficients? The coefficients increase and then decrease in symmetrical pattern. Let's see what that means. Increase and decrease. Let's see. The coefficient here is 1. It's 4, 6, 4, and 1. It's the same thing here and here. Here and here, here and here, here and here. Oh, symmetrical. 1, 1, 2, 1, 1, 1, 5, 5, 10, 10. Ah, symmetrical pattern. If you notice all those, you should give yourself about, I don't know, 20 points, okay? To feel good about yourself, okay? Now, I'm going to show you another pattern and see if you guys notice a pattern there and what kind of patterns, okay? But you know what, you guys, let's come back to the next pattern. I'm going to show you something else right now, okay? Let's go on to part 1. Ready? All right. So I'm going to formally introduce you to the binomial theorem in a second, but right now let's just see some things, okay? So part 1. Part 1. Do you remember what a binomial is, first of all? Do you remember that at all? What a binomial is? Do you? Okay, if you don't, you know that has something with 2. Okay? So you'll see. Okay? Just wait 1 second. Well, let's just refresh your memory a little bit, okay? If you have A, sorry about this marker. A plus B, if you have A plus B, okay? And you have like 2x plus 3y squared, right? Those are binomials, okay? Okay, so 2 things. Okay, what is that still? We'll see, okay? Now, part 1. I wrote I see you, okay? I see you, but it's actually NCR, okay? NCR that means N, I have N, I choose R. So NCR, N choose R, okay? But right now, I'm just going to define what that is you're going to do more with it later. So I could write it as n choose r, or I could write it as n r. And you can use your calculator for this too. And I'll show you where it is on your calculator, okay? But here's a formula. It just simply means you take n factorial, and you divide it by n minus r factorial and r factorial. So let me do that again. N factorial over n minus r factorial. R factorial, okay? That's the formula for n. Let's try a few, okay? So why don't you go ahead and try some? I'll do one with you. And these are all the different ways that we can represent NCR. So 8, this means 8 choose 2. That means I have 8, I choose 2. That's why I would say I see you. Okay, I have 8, I choose 2. In how many ways? We're going to talk about more about what this means, but right now we're talking about the coefficient. Binomial coefficient, okay? So 8 choose 2, it means 8 over, I'm just going to write this formula out, okay? 8 minus 2. And then 2 factorial, which means it's 8 factorial over 6 factorial, 2 factorial, right? Which would say it's, if I was to write this out, 8 times 6, dot, 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 this means 6 times 5, dot, 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 right? Times all the way to 1, all the way to 1, 2 times 1, right? So, hiya! That's all gone, and you're left with 2 divided by 56, which is 27, okay? Sorry, 28. Oh, it was 56. I'm so sorry. 28, okay? Sorry about that. 28. Or you can keep on dividing, okay? So just, you don't need a calculator, but if you want to check it with a calculator, it's really easy. All you do is go to your equation editor, and you'll see a button that looks like this, okay? Try another one. Let's try one that looks different, okay? Let's try an obvious one, actually. Let's try D. I have 8. I choose 8. How many different ways can you choose 8 from 8? That's what that question is essentially saying. Okay? But I mean, if you were, can you guys guess? If I have 8, I choose 8. How many different ways can I do that? Just one, right? Exactly. So let's just check though. Okay, 8 over, what is that? 8 minus 8. And then you have what? 8 factorial, right? So 8 over 0 factorial, 8 factorial. But what's 0 factorial? It's 1. Don't forget. It's not 0. That means you have 8 over 8, 8 over 8, which is 1, as we assumed, okay? Let's try another one, okay? Same thing here. You guys, I have 7. I choose nothing. How many ways can you choose? If you have 7 of something, how many different ways can you choose nothing? It's just going to be 1, 2. So go ahead and do the work and verify that for me, okay? 10 choose 2. Go ahead and try that on your own. Flip back the video when you're ready. Oh, welcome back. Welcome back. So you know that this is going to look like this. 7 times 6 times 9. Okay, and then okay. You can do it multiple ways, but I don't care how you do it. So it's going to be 30. I'm sorry, 120, because it's going to be, 30 times 4, which is 120. Did you guys get 120? You can check with your calculator as well. Now, wow. Okay, now before we move on, I'm going to show you something called the Pascal's triangle. And we're going to actually use the Pascal's triangle to evaluate something like this, okay? So here's the Pascal triangle. Now see if you can notice a pattern here, okay? See if you can notice a pattern here. Let's take a look. So stop the video, okay? See if you notice any patterns. What do you notice? Okay? I have a feeling that you notice some patterns, and we're gonna make the connection later as like how this all connects to what we were just doing. Okay? Okay. So if I were to go on, do you know what the next 2 rows would be? Just try to fill it in if you haven't. Stop the video though, because I'm gonna reveal the answer. If you think it's this, and this, and this, then you figured out the pattern. What's the pattern? Yell it out. 1, 1, 1. 1, 2, 1, 1. If I add 1 and 2, I get 3. 2 and 1 equals, oh my god, 3 and 1 is 4. 3 and 6. 3 and 1 is 4. That's how you keep on going. So write the next 2 if you want to have some fun, okay? Now, this is called the Pascal's triangle. Pascal's triangle. And I want to show you a couple of things here. This is n equals 0. This first row is n equals 0. You have to understand that it starts at 0. So n equal 1 is here, n equals 2 is here, n equals 3 is here, n equal 4 is here, n equal 5 is here, n equals 6 is here, n equals 7 is here. I'm sure you noticed some pattern here, huh? What do you guys notice about this? Okay. What do you notice about here? Okay. First two rows, I don't know how much you can tell, but 2, this number is 2, huh? 3, these two numbers are 3. 4, this number, huh? The fifth number, 6, 7. So the second number always tells you the n value. Okay, n is always equal to the second value. Ooh, I'm sure there's a lot of things that you guys notice here. Like it's symmetric, like we talked about earlier when I showed you guys the binomials, right? Okay, so for example, this case is like the case that you saw earlier that goes like that. Because, what's that? 1, right? Okay, this case, what do you think it's going to be? X plus y, and you have to put 1 power, first power. N goes here, right? N equals 1. And that's going to be x plus y. How about here? X plus y squared, right? Because n equals 2. And that is x squared plus 2xy plus y squared. Oh my god. If you notice it, you're getting really excited. So why don't you write it all down? X plus 3, x plus y to the third is going to be what? 1, 2, 1, 1, 1, just 1. So maybe, I don't know, but maybe x cubed plus 3x squared y, because remember we talked about this, the x exponent decreases, y exponent increases, plus 3xy squared, because it's 3, these are the coefficients, and then plus y cubed, because x went to 0, the y increased. So what do you suppose, can you guys see this? What do you suppose is going to happen on the fourth row? Let's just go over here, okay? Oh, so it's going to be what, x to the fourth, perhaps? Plus 4x cubed y, but remember, it has to add up to 4, so it's going to be good there, plus 6x squared y squared, that equals 4. Can you guys see this? Plus, oh my gosh, 4x1 y cubed, and your last term, plus y to the fourth. Can you guys see that? All right, so you get the point and how they're related, huh? Okay, so the Pascal triangle basically tells you all the coefficients that you should expect based on your term, okay? The row of your Pascal triangle tells you the coefficients of your polynomial, okay? So now I have a question for you though. So I'm not a question, but I have something for you here. Number 2, you have this course, this NCR part, this is your NCR representation, okay? And this tells you 0, choose 0, 0, choose 0 is going to be 1. 1, choose 0 is 1. 1, choose 1 is 1. If you calculate all this NCR values here, you get these coefficients as well, these constants, okay? I have another way to write that. You see how these are all the same? 0, 0, 0, 0, these are all the same. So I'm sure Ms. Chang has given you this shit already, okay? And you can think about how they're all related and what they mean now. Their true meaning, okay? This is n equals 0, don't forget, and this is n equals 1, and this is n equals 2. If you ever forget which term it is, just look at the middle term, or the second term, second row, okay? All right, so let's come back to that later. So now what I'm asking you to do is this, okay? Now let's go back to your notes. Let's finish that example. It says here, oh, let me erase that part. It says here, use the Pascal's triangle to evaluate this. Okay, what does she mean by that? So in this example here, which row is this? If it's n is 7, which row is that? That's going to be row, you're right, it's 8, because we started at 0, remember? And this guy is what? Is it the second entry or is it the third entry? It's actually the third entry. What does that mean? Okay, what does that mean? Okay, so let's go to your Pascal's triangle. Let's go to your Pascal's triangle now. Okay, let's go to your Pascal's triangle. It says row 8, row 8, row 8, okay, row 8, and it says third entry. Ready? Because remember, it goes 0, 1, 2, 3, 4. Okay, so 0, 1, 2, 3, 4. So 7, 2, which means n, which means NCR, right? So it's 7, choose 2, which is also 7, 2. So you can go here, 5, 0, 6, 0, 7, 0, and this is n equals 3, right? And this is n equals 4. Okay, so we know that we're going to the 8th row, so we're right here, because this is the 8th row, and they want the 3rd entry. 1, 2, 3rd. It's going to be 21. Okay, that's what that's telling you to do. So if it says to use the Pascal's triangle to evaluate, that's how you calculate that. But not super important, right? Because you know how to calculate this. Because you know it's a 7 over 5 factorial, 2 factorial, which is 7, 6, 5, 5, and everything beyond goes away. 5 and beyond goes away. Haya, haya, and then you have your 2 times 1. Okay, which is going to be 21 anyways. Okay, let's move on to part 2. Make sure you start the next video. Bye! Bye.